Okay, you all got that? Yeah. So, like I was saying, we can call this the modulus function or the absolute function. Now, the physics students already know what this function does. What does this function do? What does this function do? What's its job? It keeps the number positive. You remember? So, for example, if you had something like this, modulus of 3, that's equal to 3. And modulus of -3, that's equal to 3 also. So, things which are positive, it does nothing to it. Things which are negative, it changes the sign. So in fact, you can write that down as the definition here. The modulus or absolute of x, the absolute of x is x if x is positive. In other words, nothing happens. And we change the sign if x is negative. This is the definition of the absolute function. Got it? So what does the graph look like? I would like you, before I draw it, I want you to try and draw what you think the graph of this looks like. So I want you to try and draw this y equals absolute of x.
Just take away the length part.
Yeah, well, draw it for me. What does it look like? Okay, you have it drawn? So, Yusra, show me what you drew. Almost. Half right. What did you draw, Lena? Half right. Show me what you drew. That's it, the V shape. For example, just think about putting in some numbers. Here's x and here's y. When x is 0, what's the absolute of 0? 0. When x is 1, what's the absolute of 1? 1. And when x is 2, the absolute? 2. And x is 3? 3. Now, what's the absolute of -1? 1. And of -2? 2. And -3? 3. So in fact, as you were saying there, Mohammed, it makes a nice straight V shape. Yeah? Yeah? What is the domain here?
All real numbers.
All real numbers is the domain. So domain is all real numbers. And what's the range?
All positive numbers.
Including 0 or not? Including 0, yeah. By the way, there is a short way to write this information. Sometimes you might see in books they write something like this, absolute, and then 2 dots like this, and the first is the domain, and then the second is the range. So like for example here, the sine function, for example, what's the domain here? It's all real numbers. And what's the range? What is it? For sine? Yeah? Come on, wake up, you're all asleep. Square root x, what's the domain?
Domain, all real numbers. Sorry, 0 and all positive numbers.
And what is the range?
0 and positive.
Anyway, I'm just showing you a different way to write domain and range. Trouble with the bus, huh?
Yeah.
Didn't leave the house late, no?
No, I was not.
Okay, fine. Okay, anyway, back to the main point here. This is the graph for the absolute function. Now, yesterday we had a look at transformation, and that will be useful for drawing more complicated graphs of the absolute function. So, I think you should be able to do this for me from yesterday's class. If I said y equals 2, 3x minus 6, and make this minus 2 plus 1, you should be able to draw this for me by using what you learned from transformations. Let me draw it for you. So first, we should take out what? The 3. And we're left with x minus 2 plus 1. Now if you want to make this clearer, we can say let fx equals absolute of x. So this would be y equals minus 2f 3x minus 2 plus 1. So now it looks more like what you did yesterday. Now you know what the graph of this looks like. I just did it 1 minute ago. We know this graph. So we can transform this graph into this. Let's do that. Okay. So first we have a nice V shape. And here is 0, 0. So let me track the 0, 0. So 0, 0. Okay. What happens with the minus 2 here? The 2 is twice as big. So what happens to 0, 0? It's still 0, 0. Okay. But it's twice as big, so the graph now goes like this. Okay. And the minus? Flips it, so now it's like this. Okay. And does the 0, 0 change? No. Right, the 3 divide the x-axis by 3 units, so it compresses it, so now it looks even skinnier, I think. And what about the 0, 0? Stays the same. The minus 2? Move to the right. Right. Minus 2 to the right, 2 units. So now it's over here. And this does change now. What will it become? 2, 0. And finally the plus 1? Moves to the up, yes. 2, 1. So now it looks, like this. And this here is 2, 1. Okay, let's draw it and see what we get. So I would just like you to read this function back to me. Whoops. So we have f of x is the absolute of x, and I want to draw, so can you read the function to me? Y equals minus 2, f, yeah. 3x minus 6 plus 1. Is that what we have? Alright. Let's see how good of a graph I drew. Not too bad. It's like exactly the same. In the exam, sometimes they want you to find these points where it crosses the x-axis and, although you can't quite see it, sorry, where it crosses the y-axis as well. So sometimes in the exam, well not sometimes, in fact most of the time in the exam they want you to list the y-intercept, the x-roots, and the, what's the name of this point at the top here? Turning point, yeah, or vertex. So what I'm going to do next is show you how to I'll show you how to do that in a moment. So we have some basic graphs drawn. Okay. Now, can I just have a look? I think the first question, though, I ask you to do is to solve some equations with absolute. And in a moment, we'll go back to finding those points on the graph. We want to solve this. There are two ways to do this. But before I even start, there is one thing I can do to simplify it. I can divide by minus 4. So I'd get absolute of x minus 3 equals 4. Now there's two ways to do this. I'll show you both ways. The first way is you go, okay, if I have the absolute of a number and it's equal to 4, that can only be because the number on the inside was equal to plus or minus 4. There's no other way that it could be 4, unless the inside here was plus or minus 4. The only way it could happen. Therefore, x must equal 3 plus or minus 4. So x equals 8 or minus, not 8, 7 or minus 1. There is another way to do it. Now if you think about it, what have you done in math that has two answers? Quadratics. So there is a way to do this with quadratics. So just for a moment I'm going to go to the side just to give you an idea. Then I'll go back to this. Okay, so for example, I have 5 squared. What do I get here? 25. I have minus 5 squared. What do I get here? 25. Okay. I have the absolute of 5 squared. What do I get? 25. And the absolute of minus 5 squared. 5. So what I want you to see, and we'll do it the other way around. If I have minus 5 squared and absolute, I get 25, and then lastly, if I have 5 squared absolute, I get 25. The point I'm making is this: when we have a square and an absolute together, there's no need to write the absolute, because if you think about it, when you square a number, what will it be? It'll be positive. So the absolute does absolutely nothing. It doesn't change the sign because it's already positive. So, my result here I'm trying to get you to see is absolute of x squared is the same as x squared absolute, which is just the same as x squared. You don't need to write the absolute when you have a square. That's my point I'm making here. So if you want, you can make note of this fact. X cubed, now you do need it because x cubed could be plus or minus, but then x4, no. Okay, back to the main question now. Okay. So what I'll do is I'll square both sides. Yep, I'm squaring both sides. But if I square, I don't need the absolute anymore. So I have x minus 3 squared is 16. I have x squared minus 6x plus 9 equals 16. I have x squared minus 6x plus 7. Minus 7 equals 0. This is a quadratic. This quadratic has two answers. It's 7 or minus 1. So it's the same answer. Some students like doing it this way and some students like doing it this way. It doesn't matter for the exam. Both are fine. I will tell you though, for some more difficult problems, it's actually easier to do it this way. I won't tell you which problems. I'll let you find them for yourself in the workbook. Okay, can I go back to the previous example with the graph? Yep. I have a slow person up here writing, sorry. We can go to the last one? Yeah. Okay. So if you remember, what I want to do now for this problem here, that I gave you earlier, is I'd like to find the roots, the y-intercept, and the vertex. So that's what I'm looking to do now for this. Find the x, y intercepts and the vertex. So let me just write it again freshly down the bottom. What was it? Y equals minus 2 absolute, 3x minus 6 plus 1. Now, I already have the graph drawn, so let's look at the graph so we can see roughly what the answer should be. So let me just... Okay, the y-intercept, what do you think that could be, roughly? The y-intercept. We think it should be minus 11. Now, what about the vertex? Oh, well, we know what it should be. It should be 2, 1. And what about the roots? 1.7 and 2.3 or 2 or something like this. So, let's see what we get. The first one to do, the easiest one to do, I think, is the y-intercept. Think back to semester 1. How do you find the y-intercept? What do you do? Yeah, you let x equal 0. So you get y equals minus 2 absolute 0 minus 6 plus 1. That equals minus 2 times 6 plus 1. That equals minus 12 plus 1, which equals minus 11. And what did we think it should be from the graph? Minus 11. Okay, what we'll find next is the x-intercept, the roots. So the roots next. So how do you find the roots? Yeah, let y equals 0. So now you have 0 equals minus 2 absolute 3x minus 6 plus 1. Does this type of equation look familiar? Yeah, your maths teacher just did it with you 5 minutes ago. So let's solve this one. Which method do you prefer? The plus-minus method or the quadratic method?
Do both.
Yes, I'll do both. Okay, so firstly, let's look at the plus-minus method. Minus 2 absolute 3x minus 6 equals minus 1 when you take the minus 1 over to the left. Absolute 3x minus 6 equals minus 1 over minus 2, which of course is equal to just a half. Now the only way that can happen is if 3x minus 6 is equal to plus or minus a half. So 3x equals 6 plus or minus a half. So 3x equals 13 over 2 or 11 over 2. So that means x is equal to 13 over 6 or 11 over 6. This is 2.167 and this is 2.167 and this is 1.84 roughly. Yeah, you want to check that. So this is about 2.1716 and this is 1.83, something like this. 2.167 and 6, yeah. No need for a calculator, right? Okay, so let's look at the second method, the quadratic way of doing it. So, same thing at the start. I have minus 2 absolute 3x minus 6 equals minus 1. This time I square everything. So now I get 4. 3x minus 6 squared equals 1. So I get 4 9x squared minus 36x plus 36 equals 1. I hope. Is that right? Yeah. So I get 36x squared minus 144x plus 143 equals 0. I took the 1 to the left. It was 144 minus 1. That's why it's 143. This has factors, 6x minus 13 and 6x minus 11. And if you believe that I just factorized that in my head so quickly, you're all suckers. I didn't. What? Yes, not that good, yeah. So I'm assuming that these are the factors. You can check them on your calculator if you want. So we get x equals 13 over, don't, you should definitely not trust me here. Check your calculator to make sure. Or 11 over 6. Yeah, check, I won't be offended. This is what we thought the answer should be when we look at the graph. We said, what did we say? A little bit past 2 and a little bit before 2, wasn't it? Yeah, which is what we have, which is good. Okay, the last one is a little bit tricky to get. So let me just write it down, or maybe you can just read it to me again. It's the vertex. And we have y equals, what is this? Minus 2... the function, 3x minus 6 plus 1. I think I'll clean this up a little bit to maybe help you. You can take the tree out here. Now please listen carefully to what I'm about to say. You are allowed to take positive numbers out of the modulus. And the reason you can take positive numbers out is if you have a positive multiplied positive, what do you get? And positive by negative? Negative. So when you take a positive number out, it doesn't change the sign. Okay, if you think about it like this. If you have a positive and I take this out, I have positive multiplied positive, and this is still the same. If you have positive and negative, and I take this out, I have positive multiply negative, but this becomes positive, so it's positive, positive. It's the same thing, it's fine. Yeah, now it's a big problem, I think, if you take the minus out. So if you take the minus out, you have minus and then minus. And what will this be? Minus and a plus, and a minus and a plus is a minus. But that's totally wrong, because what do I have at the start if I have this? A positive. So it's totally wrong to take out a minus. But it's no problem to take out a plus. So I'll take the plus 3 out, and I get y equals minus 6 absolute x minus 2 plus 1. Okay, so I haven't done anything except clean it. Now, does anybody have any ideas on what I should do to find the vertex here? Absolute does not have a derivative. Squaring? Possible, but complicated. Any idea? Well, in my graph, what is the vertex here? A maximum or a minimum?
Maximum.
Maximum. Now, I have two numbers here. The first number, the minus 6 absolute x plus 2, positive or negative? Negative. And plus 1? Positive.
Zero.
Yeah. You see, yeah, the first number is negative. So when I put that with the 1, does it get bigger or smaller? It gets smaller. So the biggest value I could get is when the first piece is 0, when I can no longer remove anything from the 1. So in other words, if I want to find the vertex, I need to make this piece equal to 0. So that means the x equals 0. And when the x is 0, what do I have for the y? 1. So in other words, the vertex is what? 2, 1. This should remind you of something from semester 1. Completing the square. Let's compare this to completing the square. If I had y equals minus 6 x minus 2 squared plus 1, where's the vertex? It is at 2, 1. So why does it work for this problem, even though it's different to a quadratic? And the reason comes down to this. The piece here, this piece here is always positive. And what about this piece? Always positive. So I'm going to give you a general idea here. If you have y equals a plus a thing which is always positive plus a b, the vertex will always be the x that makes this 0 and then the b at the end. Just like what we did in completing the square. It's exactly the same thing as completing the square. So the vertex here is at 2, 1. We make this piece here inside the absolute 0, and then we take this piece at the end for the y. No difference. No difference. Yeah? Okay. Two more things to look at now. So now that we had a look at graphs, and equations, I also now want to have a look at inequalities. So this is if you have absolute less than some other number. Can I scroll down a bit? So, for example, how can we deal with problems like this? Minus 5 absolute x minus 9 plus 3 greater than or equal to minus 2. Well, it's not really any different to when we were solving equations. I don't recommend plus minus here. It's okay, it's just a bit messy. I think quadratics work nicely here. First, I will take the 3 to the right, and this will be minus 5. Then I will divide by minus 5, and so here this flips, and I get 1 here. Next, I'll square both. So here I get x squared minus 18x plus 81 less than or equal to 1. So I get x squared minus 18x plus 80 less than or equal to 0. Does this problem look familiar? Have you solved these quadratic inequalities before? Yeah. Semester 1. The last worksheet in chapter 2. This is going to be factorized as 10 and 8, x minus 10, x minus 8. A very quick sketch here gives us the answer. What are the two roots here? 8 and 10. Do I want the piece above or below?
Below.
Below. So x is between 8 and 10. Okay, you have that? Yeah? Now, there are other examples. I don't think I'll do it because I think you get the idea. If you have an absolute on the left and the right, you can do it the same way. You can square both sides, and both sides will become quadratic. And then what do you do next?
Solve the quadratic.
Just before that, yeah, like what, how do you solve it? What do you do?
Take the absolute. No, take the answer.
Yeah, so if you have an absolute and an absolute, and you square both of them, you get a quadratic and a quadratic. You take one of the quadratics to the other side, and now you just have one quadratic equals 0. It's the same thing. And likewise, if you have one absolute is bigger than the other absolute, what do? Square it, take it to the other side, and it's the same type of problem. So there's nothing more interesting to say. One last example, a different type of problem to look at. I'll give you a minute to try it and then I'll show you. I want to see what you draw. I would like you to try and draw this. Let's use a different verb. I'm tired of draw. Sketch. No. Sketch. Plot sounds too neat. I don't want it neat, just roughly. Sketch y equals absolute x squared minus 3x plus 2. I'll give you a minute or two to try and draw this for me. I want to see what you draw, then I'll show you. No cigar. Any ideas, Louise? Too difficult, yeah? What about you, Phil? No, definitely not. Abraham? No. Now we're talking. Not quite. Way off. I know what you're thinking, but no. Any ideas here? No? Any ideas? Yeah, some people have half of it. So what's your final answer? Got it? See, you're so close, but not quite all the way there. Show me. Again, like Lugo, you the same type of work. Which one am I looking at? And is there a pixel to me?
Yeah, please.
Is it the same?
I don't think so. Let's see. Not this.
The opposite?
Not that either. I'll show you now. Okay. So the first thing we do is let's just look at the quadratic on the inside. So here we have y equals absolute x minus 2, x minus 1, absolute. Now if the absolute wasn't there, what type of graph would this be? I'll draw it in red. It'd be what shape? Yeah, U shape. And where are the roots? 2. Yeah, 1 and 2. So in red, this is what the quadratic looks like. But then I compose it with the absolute function. I put it inside the absolute function. So what does absolute do? Change a positive to a positive and a negative to positive. So, here, is the quadratic positive or negative? Or actually, let me go further back to the left. Here, let's start here. Is the quadratic height positive or negative? Positive. So does the absolute do anything to it? No. Positive, 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 positive here. Now here, for example, let's say the height here, I don't know, whatever, 3 units down. This is minus 3. What would absolute do to this? It'd be 3. So in fact, what happens is the absolute will flip this to the positive. So the graph will go like this, and then continue. So you see, some people were halfway there. Some people thought, okay, I should now delete this piece because it's negative. Not quite, almost, not quite. And some people just drew the quadratic normally. Not quite this either. Let me show you it neatly in the graphing program. I think it'd be better. Okay, can you just read it back to me? Wait 1 second, sorry. Okay, y equals absolute of x squared minus 3x plus 2, isn't it? Okay, let's graph. Yeah. Weird. Oh no, not this. Yeah, something like this. So you can see that the piece here gets flipped, reflected through the x-axis. Huh? 1 and 2, wasn't it? Oh yeah, no, I just made up a number. I didn't know how far down it was. Yeah, no, it's not 3. It's more like a half. Yeah. I've seen this question only once in the exam, but it was recent, so it makes me not worry, but wonder, I suppose, if it'll be on the exam again in the future. So it's a new question. I've not seen them ask for this graph until maybe last year. So I don't know if they'll do something similar again. In other words, when you put an absolute around side a function, you draw it normally, and then at the end, the negative pieces, you flip them around to the positive. So it's not a major problem. Okay. So I recorded this lesson for intake 1, but the video actually broke. And one of the students in intake 1, maybe you know him, Ali? Do you know Ali? Yeah. He asked me, oh, the video's broken, I need a new video. And he asked me this yesterday for this lesson. So if you want, you can all say hi to Ali. He's going to be watching this evening. So anyone want to say hi to Ali? No? No. Sorry, Ali, nobody wants to say hi to you. Yeah. Well, we think of a message for Ali. Okay. Is he doing the child exam? Does anyone know? So just to be clear, Ali, intake 2, they don't care about you. They don't care if you're doing the child exam. Any other messages? Yeah. They don't know who you are. And good luck in your final exam. Yeah? Okay, we'll leave it there. So.